Welcome everybody. Today we're going to be talking about exceptions in C++. So exceptions are a way for a function to indicate an error occurred other than returning some sort of guardian value out of a function. For example, let's say you're talking about the S2I, STOI I call it, string to integer function, where you pass in a string and it's supposed to return an integer for you. Now, you might say, well, if an error occurs, return 0, but then what if they tried converting 0, the string 0, double quote 0 to an integer, then you wouldn't know if an error occurred or if, they were just converting 0. So the only thing that a function like STOI can do is throw an exception. And that's a different way of returning from a function. And if you do not catch the exception, it kills your program. If you do catch the exception, then you can handle it. And in fact, if you want to, I know some of you wrote your Pokemon Part 1 thing where you just keep trying to, STOI things over and over. Once you hit the end of file, you get an empty string. You try converting that to an integer using S2I, and it throws an exception. And then when you catch the exception, you just break out of the loop and go on. I don't recommend doing it that way. I did show this to you last week, though, so, fair enough. If it works, right? So, but today, though, we're going to show you the full-on lecture on exceptions. Okay, so let's take a look at this. Let's say we've got a function here called integer square root. Okay, and it's going to take in another integer. Maybe we should be using doubles or something. It's kind of weird to talk about doubles without with just integers. Okay, and I don't know, maybe let's do let's do this integer square root. This will be fine. This will be fine. Okay, so we'll do a for loop for and I equals 0. I is less than x. Less than or equal to x. This is going to be the dumbest square root function ever. I love it already. So what we're going to do is we're going to try every integer up until x, and if we ever find the square root, we return it. This is the absolute worst square root possible. Okay. Okay. So if I squared is equal to x, then we return I. And if we get to the end without returning anything, then maybe if we ever exceed it, let's say if I times I is greater than x, then we will return I minus 1. All right, so like let's say we're trying to do like the square root of 20. When we have 5 times 5 is 25, so we're going to return 4 because the square root of 20 is 4 point something. And then we got, and then what if we get to the end of the for loop without finding anything? I don't think this is possible, but you see how C++ is kind of like, you should probably return something here, right? Because C++ can't prove this mathematically, so we'll just return 0 if we get to the end without anything. And the reason for that is because there's that one particular C++ is rather annoying. It's not actually. You really should pay attention to every warning that you see. Every warning is there for a reason. Unless you're going like super down the rabbit hole of warnings, like with Kling's dash everything, dash W everything thing. You should really have 0 errors, 0 code, 0 warnings in your code at all times. Okay. So let's see out the square root of 16. See out the square root of 20, square root of 25, and the square root of 0. And you can see square root of 16 is 4, square root of 20 is 4, square root of 25 is 5, square root of 0 is 0. Great, we have the world's worst square root function. But there's one thing that we are not handling correctly. So about half of all integers we are not handling correctly. Anyone want to know which integers we are not handling correctly? Anyone want to chime in on chat? There's a lot of numbers that this code doesn't work for. Zero, it handles, like the square root of 0 is 0. Right? I guess, maybe. I don't know. Probably not. Who knows? 1. I don't know. Let's try with 1. Yeah, square root of 1 is 1. Yeah, sure. Why not? Okay. So what about floating points? Yeah, I was going to do it with floating points because square root's kind of weird without floating point numbers, but just on the whim of the moment, I decided to do an integer-based square root, which is ridiculously bad. So, negative numbers. Yes, negative numbers are not handled correctly, right? Because what is the square root of -1? 0, right? Wrong. So we can't handle that. All right. So just in the floating point numbers, the GPU uses. Now SIMD doesn't send the numbers to the GPU. SIMD does it inside of the CPU. Okay, so how do we handle this? And so this is what exceptions are for. Okay. So learning point number 1: exceptions are really for the case when a function can't return a value that they said they were going to return. Like there's literally no integer that we could return here that would be accurate, right? Because we can't express imaginary numbers using an int. Now, if we included like the complex, like C++ actually has support for complex numbers and things like that, maybe we could. But we're saying we're just going to return a regular non-imaginary integer here, right? So your predicted classes made you program using exceptions in Java this semester. And exceptions are necessary. Okay. So philosophically speaking, though, like when you can't, like there's no number I can return here that would make any sense, right? That's when you throw an exception, okay? And so this is what the syntax looks like. So learning point number 2, you throw an exception using the throw keyword. And you can throw anything. You can throw anything, but we usually throw exceptions. Exception class exceptions. I don't know, like the terminal, like the. Okay. You'll see what I mean in a second. Okay, so if x is less than 0, then we are going to throw. We could throw anything. We could throw a number if we wanted. Throw 42. We could do that. We don't. Like in computer science, we don't throw integers. We could, and I'm going to show you that what happens. If you do not catch an exception, it will kill your code. Okay. So if you throw an exception, and we can stick this like down here somewhere, it's going to print 44 and then terminate. Okay. So when you throw an exception, it's like an alternate way of returning from a function. Okay. So instead of returning an integer, it throws. And if you do not catch it, then it kills your program. All right. So how do we catch it? Learning point number 3. If you have a block of code you want to catch exceptions in, you use a try catch block. Okay. And it looks like this. Try. And catch. Catch ... will catch any exception. But usually we are more specific about the exceptions we catch. Okay. So we get down here and say cout something wrong. See that? Code doesn't die now. And in fact, I can come down here and say the code continues. Right? Just because you have caught an exception doesn't terminate your program. You guys see that? So when we run that line of code, it computes the square root to be 4. When we run this code, it computes the square root to be 4. When we run this code, it throws an exception. And then when you throw an exception, it's like a go-to statement if you've heard of those. And in fact, in C, they do exceptions by using go-to. So what happens is it stops running this code and it jumps to the catch block. And we're saying catch every possible exception that can be thrown. And whenever that happens, we just print out something went wrong, and then the code continues, and then it'll just keep running. And so this is kind of a generic sort of like catch everything and sort of ignore it, but at least print, hey, something went wrong kind of thing. Not really the best coding style in the world, but, you know, at least your code doesn't die. I don't know, like, you know, in case something goes wrong. So not super great coding style. So let me show you a better one. Okay. He just taught us the method. Yeah. If your code's crashing with stoy errors, then this will fix it for you. What's going on, girl child? What do you think of computer science? Do you like computer science? She's going to be a computer science. Just like her daddy. Okay. Math major. Yeah. So let me show you the better way of doing it. So rather than throwing an integer, we typically throw an exception. Okay. And exceptions are found in exception and also in stdexcept. And I don't know why they put them in 2 different header files. They just are. Exception is the main one, and then stdexcept creates more finely detailed exceptions. So you can just throw something called a generic exception like this, and say, does that even work? No, it doesn't even work. Yeah, you just throw an exception. And then you get the same thing, something wrong, because our code is catching anything. But if you use stdexcept, there are more detailed kinds of exceptions you can throw. So for example, you can have runtime error, which is kind of a generic term for like, hey, something went wrong when our program's running. And this one, you can actually pass a message out. And so for this one, you can say, you tried square rooting a negative number, you moron, like that. And then down here, we can actually catch a runtime error named E, which we'll catch by const reference. And then, rather than just a generic sort of like something happened, we can actually say exception caught, and there's actually a member function called what that will return whatever message was put in when you created it. Okay. So this allows you to get more detailed information. If you've got a bunch of possible runtime errors coming out of your code, being able to look at the what on it will be like, oh, this happened. Oh, this, you know, our printer caught on fire, you know, which is actually an error message in the Linux kernel. Exception caught. You tried square rooting a negative number, you moron. Back in the day, like I don't know if you guys have ever seen like high-speed line printers. Like those things went through. Those things shot paper so fast it actually Like I watched it at my college. They would actually shoot, like the paper would actually fly up into the air. It was moving so fast. And so they were actually put into fireproof rooms because all the friction of all the paper flying through it so fast could actually rub it and heat up hot enough the paper would actually burst into flames. And so they were kept in like these like steel lined rooms, and like it was crazy loud. Like those things are, and the paper is just fountaining up like this, and then it folds in midair and lands in a box, and it would just print out like hundreds of pages a minute or something like that. Crazy. The fire danger, yeah, they still use them. Like if you have need for like a lot of printing, like, and you don't care about quality, it's pretty good. But that's like, you know, the old school like IBM mainframe, you know, kind of thing. So yeah, in the Linux kernel, there's actually an error code for printer on fire, you know, which is a legitimate a legitimate worry for those things. Okay, so let's say I don't know, somebody come up with some other error that we can have here. What is another error that can happen? Maybe, I don't know. That's about all I can think of for square root. Why is a const reference? Because if you do it like this, it'll duplicate it, and so I think it'll slice it too. So the reason why, like, you won't know what slicing is until CSI 41, but basically just do you remember the rule that I told you before? Like anytime you have an object, anything of a class type, you should always do it by const reference. That's just your general go-to rule for everything. The only time you don't make a const is if you want to change it, and I clearly don't want to change it here. I'm just catching it. And so that's just yeah, like whenever you do a range base for loop, const reference, you know, unless you're trying to change it. I don't know, I'm just gonna make up another error, like if x is equal to 13, throw runtime error. Sorry, I have triskaidekaphobia. Zero confidence I spelled it correctly. Triskaidekaphobia. Very close. I came close to it. So triskaidekaphobia is the fear of the number 13, right? So there's actually a lot of buildings, especially older buildings, that don't have a 13th floor. So people think they're unlucky. You know? Triskaidekaphobia. Okay. So then if we change this -1 here to a 13, then you'll see, sorry, I have triskaidekaphobia. Yep. You guys understand? So you can, so if there's different things that can go wrong, you can use the what method to find out the error message. You can even like have an if statement. It's like, oh, if, you know, they returned, you know, oh, I'm sorry, I have triskaidekaphobia. You can handle it maybe differently. I don't know. What else? You can also throw different types of errors too. In addition to runtime error, there is logic error. That's the other main category of exception. There's far more like exception types than that. So doesn't have children here stood accept. Okay, so there's a length error, outer range error, overflow error, underflow error, and so overflow error is a type of runtime error. Underflow error is a type of runtime error. Length error is a type of logic error. So basically, all these guys are either runtime errors or logic errors. You can be more specific in the type of exception you throw. But here, let me show you this. So we've got here a runtime error, and we got a logic. It's not really logic, whatever. You can actually have multiple catch statements. Okay. So catch logic error E, and runtime exception caught, logic error exception caught. Okay. And so what will happen is it will, whenever you have a multiple catch blocks, it goes through the catch blocks one at a time. Okay, did we throw a runtime error? And the answer is no, because we're returning a logic error. So it's going to skip this catch block and do this catch block instead. It'll say logic error exception caught instead. So it says logic error exception caught. Sorry, I have Triskaidekaphobia. And there is a more generic type called exception that will catch any type of exception. So warning, yeah. So it matched on the first one this time. So the exception class can catch any type of exception, including runtime errors, including logic errors, including all the children of the runtime error class, all the children of the logic error class. It'll catch all of them. And so I'm getting a warning here because I'm catching exception first, this guy can never be caught. So we can never catch a logic error because the logic error is an exception, and an exception is first in our catch blocks here. Now, if I did it the other way, it'd be fine. So if we switch this out to -1, then it's going to throw a runtime error, and so as it goes down the catch blocks, it's like, oh, we're returning a runtime error. Okay, yeah, cool. Runtime error exception caught. And then if we were to throw a logic error instead, like that, then it's going to print this one. So how is const exception E different from using logic error? Well, because we can also have logic error in there, right? So we could have that. And then this. So if we throw a runtime error, it'll print out runtime exception caught. If we throw a logic error, it'll say logic error exception caught. And if we throw any other kind of exception, it'll say generic exception caught. So for example, if up here we say if x is equal to 42, throw bad alloc. Okay. Which you normally use for like if you knew something and you run out of RAM. I'm running out of ideas here. The squirt function can't really fill them anyways. But if we throw a bad alloc, then it's going to catch a generic exception, because the generic exception class can catch every kind of exception. If we throw a logic error by using 13 here, then it's going to throw a logic error, then it's going to catch this one. You guys understand? Makes sense. What if we said if x is equal to 50, throw 9001? What is this going to do? What is this going to do? We're throwing an integer now, not an exception. So what's it going to do? What's the code going to print? It's going to start off by printing out 4, because the square root of 16 is 4. Then it's going to print out 4 again, because the square root of 20 is 4 in integer world. So what's it going to do when we get to the square root of 50? And it throws an integer. This is why I don't like the word. It's not part of the exception class family of exceptions. So you have exception, and then the children of exception are runtime error and logic error, and then it's got some other things like bad alloc, and then runtime error has like out of bounds or whatever, and logic error has like underflow and overflow. That's children of them. An integer is not none of those. So it is going to crash our code. Okay, because we are not catching it. So we could add a catch block for it. All right, we could if we wanted. And again, people don't throw integers, generally speaking. You got like cout integer thrown error code. So we could catch it, right? If we wanted to, but generally speaking, people throw exceptions, exception class exceptions, rather than throwing integers or strings or things like that. They're easier to deal with. You guys understand? And then you can finish at the very end with a ... And so if it's none of those above, then it'll catch it and your code won't die. So all of these things you can do, and they all get checked in order. Was it a runtime error? Was it a logic error? Was it a generic exception? Was it an integer? Was it anything else? You know, so if our code up here were to throw a string, hello world, right? Then it's going to say something else was thrown, right? Because a string is not a runtime error. It's not a logic error. It's not an exception. It's not an integer. Okay. What if we did this? What's it going to print? We're throwing 42 now. Everybody. We got 12 people online right now out of the 40 in the class. What's it going to print to the screen? Integer thrown, error code 42 is correct. All right. So let's mix it up. What about now? Added a dot there. What does that mean? Something else is thrown is correct. Yeah, this is a double, right? And so, okay. So that's basically it. What you might see also is something like this. We have like an integer pointer array equals new r size 100. Actually, null pointer. So if, let's say somewhere within our code here, we're like having a new. If you throw an exception, new array, new integer. A lot of times your catch blocks will involve just cleaning up things. So if you're like allocating RAM or something like that, and you throw, you need to undo anything that was allocated within the try block, right? And so you need to clean up after yourself. So we could just say delete r. Do you guys see that? So like maybe this line up here through, maybe this line down here through. It doesn't matter. If array is null, then deleting a null pointer does nothing by definition. If it makes you happy, you could say if r delete r. But if you have a null pointer, it doesn't hurt anything to delete it. So basically, if r was allocated, it's going to free the memory. You guys see that? So we don't know. Maybe at some point during this try block, something happens, and we need to make sure that every new gets one delete with it. So it's very common to have a catch block like kind of like bookend any sort of allocation you make. So if you open a file in the try block, you close it in the catch, right? If you open a network connection and some exception gets thrown, you catch it and close the network socket so that you're not left with a. So you're not left with a. Let's do that. It's like, you just kind of going along, and normally under the normal flow of code, it would delete it. But if something happens and some exception occurs, you have to clean up after yourself in the catch block. Does that make sense? Because every new needs a delete. It's the yin and yang. It's the rule of the Sith Lords. For every master there is an apprentice, right? Every new needs a delete. And so if something goes wrong and an exception gets thrown, then let's move it up here maybe. If something goes wrong and an exception gets thrown, then you need to clean up after yourself in the catch block. That's kind of the main, most important thing for it, other than just like error handling and stuff like that, is that the catch block gives you a place where you can, close any open files, close any open network sockets, delete any memory you deleted, things like that. Does that make sense? Again, I would just use a vector, because vectors handle all this automatically. You don't have to worry about news and deletes anymore. But yeah. Okay, so that's exceptions. That's about all there is to them. They're not too bad. Your Zybooks on the topic will be on exceptions this week. If you're curious, you can look at all the different kinds of errors, invalid argument. Do you have to memorize all these? Nah. The only two that the only two that kind of matter is runtime error, and that's one of the big categories. The other one is logic error up here, and if there's sort of a philosophical thing, like which exceptions should I throw? Is this this one, or is it this one? And it might be worth going through std except and kind of reading which one you're supposed to use. But honestly, I just use runtime error a lot. You violate a precondition, use logic error. If you want to be philosophically correct, then go through CPP reference and read about the different exceptions, especially if you're writing code that other people are going to use, because they'll get mad at you if you throw out of bounds when the number was too the temperature is supposed to be between 1 and 100, and you throw out of bounds. You're like, what? That doesn't make any sense. So I would just use a runtime error or something in that case. Logic, runtime, and generic. Those are basically the only three that I really use, to be honest. It's probably something I could probably work on more, just learning all the different intricacies of all the different kinds of exceptions. So I'm more proper when I'm throwing them and stuff like that. But I normally just use runtime error if something happens at runtime that's bad. So that's it. You guys have lab time for the rest of the day to get Pokemon Part 2 working.